Hello there, eighth graders. Welcome back to week 4 of our e-learning curriculum. So last week we did our first Google video, and this week is going to work out a little bit better, I think. I have a feeling that we are going to be able to rock and roll a lot better here. So what I would like you to do is I'd like you to go on to Google Classroom, make sure that you've taken a look at our weekly agenda. This week we are going to be reading from the CK12 Classifying Triangles article. So make sure that you have that up, please. Follow through with this video. If you want to print off the textbook, you're more than welcome to. But just follow along here. I'm going to read this whole thing with us, and we are going to be solving these problems together. You will want a notebook and a pen or a pencil in front of you, preferably, so you can take notes as needed. At the end, we are going to have a short assignment, just like we did last week. If you have any questions or comments, you can always Google Hangout me. I'm available from 9:30 to 10:30 every single day, and from 1 to 2. So without further ado, let's begin. So we are on CK12, Classifying Triangles. So let's begin here. Do you see these beautiful strings of flags? These are called buntings. So we're going to be learning about Marjorie. Marjorie has just returned from her friend Chandra's cottage, where Chandra has hung up some beautiful homemade bunting from the ceiling. Marjorie has decided to brighten up her own space by making some bunting too. She wants the point of each triangle to come down at least 16 inches from the string. So she wants her point, if you look over here, to come down 16 inches from the base, right? What type of triangle will Marjorie use to make her bunting? So what kind of triangle is this triangle that we're working with? Today's lesson is all about classifying what kind of triangles there are and giving us an idea of how to follow along and identify these triangles in our own lives. So we are classifying triangles. That is what we are doing. Classifying triangles. Okay, so a triangle is a plane figure with 3 straight sides and 3 interior angles. So you can see here, we know what a triangle are. 1, 2, 3 angles, right? And 1, 2, 3 sides. So we know what we have. That is a triangle. You guys know what triangles are. You've been in kindergarten before. So a triangle can be classified either by its angles, and that's what we learned about last week was angles, or sides. There are 7 types of triangles, so 7 types. They can be classified either by angles or sides. The sum of 3 interior angles of a triangle equals 180 degrees. If one of the triangles measures exactly 90 degrees, then the triangle is right. So if it measures exactly 90 degrees, it's a right triangle. The other 2 angles of the triangle share the remaining 90 degrees. These angles are called acute angles, since the measure of each angle is less than 80 degrees. Do you guys remember that? How we had triangles that were, or angles that are acute. Do you guys remember that from last year? Let's see if this opens up, if we can actually edit it. So can't really do that. No, that's a bummer. That's okay though. We're going to get started here. We'll just work on our sideboard here. So if one of the angles measure exactly 90 degrees, this is a right triangle. So we have a right triangle right here, right? Because that is exactly 90 degrees. This little image right there represents 90 degrees. No idea why I did 2 degree symbols. 1 degree symbol is enough. So these angles right here are acute angles, since the measure of the angles are less than 90 degrees. The following diagram is a right triangle. The right angle is indicated on the box of the corner by point C. So you see vertex C right here, that point. This triangle, or this box right here, represents a right triangle. So we have angle B and angle A right there. The vertex, the angle at the vertex of A, so right here, is an acute triangle. The name indicates that each of these angles measures less than 90 degrees. So A and B each measure less than 90 degrees. So right over here, we have a different type of triangle. This is called an acute triangle. So before we were dealing with a right triangle, here we have an acute triangle. So we have A, B, C right here. Now, do you see how each of our triangles are less than 90 degrees? Angle A is 55 degrees. Angle B is 67 degrees. Angle C is 58. These are all less than 90 degrees, so that is an acute triangle. So we've covered two of our triangles right now. Number 3, we have angle or triangle E or DEF. I'm going to retry that one. DEF. So angle D is 41 degrees. Angle E is 100 degrees. Angle F is 39 degrees. So angles D and F, they're each less than 90 degrees. So they would be acute triangles, correct? But angles E is above 90 degrees. It's 100 degrees. So ladies and gentlemen, this angle right here is obtuse, correct? So this would be an obtuse triangle. An obtuse triangle exists when you have an angle that is greater than 90 degrees and less than 180 degrees. So that was angle or triangle number 3. Triangle number 4, this one is pretty easy to remember. Triangle A, B, and C. Now each of their angles are the same. Each of them would be acute because they are less than 90 degrees, correct? And if they're the same, that means that they all have to be even. Triangle, the angles add up to 180 degrees. And if we have 3 angles, what's 180 divided by 3? It is 60 degrees. So they are all 60 degrees. This is what we would call an equiangular triangle. It means that they all are the same, have the same amount of degrees in their angles. So we just covered 4 different types of triangles, and we measured them by their angles, right? Now we are going to we're going to get rid of that. We're going to forget about our angles. We're going to be worried about the length of each triangle, of the sides, okay? So, in addition to these triangles named with respect to their interior angles, there are 3 types of triangles that are named with respect to the sides of triangles. A triangle that has 3 equal angles equal in measure also has 3 sides that are equal in length. So let's look at our triangle again. A, B, C. All of them have equal angles. We just looked at this type, right? This is an equiangular triangle. Now, the sides correspond with the angle that's across from it. So right here, do you see this little dash that I just made? It corresponds with angle C. The length does. So angle B corresponds with this side right here. And angle A corresponds with this side right here. So I'm just going to highlight here. Shows up. Angle B, that's green. Corresponds with that side right there. Angle A, actually that's not the right color. That's green as well. A is going to be purple. So we have purple, that corresponds with this side right there. And angle C is red. Well, I thought it was going to be red. There we go. That's going to correspond with this side right here. So they each correspond with the side that's opposite to it. So if they are all equal, do you see these dash lines right here? That means that if two sides or more have the same number of dashes, that means that they are equal to each other. This, my friends, is what we call an equilateral triangle. Okay? An equilateral triangle makes it that each side is the same. So that was triangle number 5. Let's talk about our next one. So we have triangle A, B, and C. A, B, and C. So A and B are the same measurement. The ones that are directly across from them, so for B, it would be this side right here. In angle A, it would be this side right here. They have the same length of their sides, right? See that right here? Same length corresponds with our angles. This is what we would call an isosceles triangles, friends. So an isosceles triangle is a triangle with 3 sides. If the triangle has 3 sides equal in length and it has 3 angles equal in measure, then a triangle with 2 sides equal in length has the opposite each of the equal sides in equal measure. So we covered that already. Angle A corresponds with this side right here. Same thing for angle B and this side right here. This is what we call an isosceles triangle. So let's get to our final type of triangle, my friends. So you can see it right over here on the left, but let's rewrite it. Actually, that's a little too perfect. Actually, this will work. A, B, and C. Now, what do you notice about this triangle? This is the triangle. There is no markings where the angles are. And there's nothing where you would demonstrate that sides have the similar length. So that means that all of the angles are different and all of the lengths are different of the sides. This is what we call a Salin triangle. Okay? This is what we call a scaling triangle. That means that they're not the same. So let's take a look here at angles 1, 2, 3, and 4. I'm just going to zoom in on them. Angle 1, my friends. What do you notice about that loop? That means that one of them is way bigger than the other 2 angles, right? At the very top, you can see right here, means that is way bigger than the other 2. So that means that this angle is greater than 90 degrees. So this would be an angular measurement angle. So based off of angles, if we have one that's greater than 90 degrees, remember, look up earlier, up here, we had this one, DFE, that would be an obtuse triangle. Angle 2, you can see, let me just clear the page here. Angle 2, we have this little sign right here. That means it is a what kind of triangle? It has that sign. That would be a right triangle. Nice job. Angle 3, you could see, has no markings. If it has no markings, for its angles, that would mean that they're all less than 90 degrees. So that would be an acute triangle. In angle 4, they all have the same. What kind of triangle would that be? An equiangular triangle. Nice job. These 4 that we just covered are all of our first 4. Those are all the angular ones. Now, these 3 back here, we see nothing to do with their angles, but we do see with their lengths. So we have angle 1, which has 3, 7, and 7. Give my Chromebook a second to catch up with me. So you can see two of them share the same length. What kind of triangle would that be? That would be an isosceles. An isosceles triangle. Don't you guys love technology? Sometimes it takes a little while, but we eventually get there, don't we? So angle or triangle 2, they're all 4.3, 4.3, 4.3. They all have the same length. Each side has the same length. What kind of triangle would that be? That would be an equilateral triangle. Nice job. Now, last but not least, number 3. Number 3, my friends. That one looks like a weird triangle, right? So 4.1, 8, and 5.5. They do not share the same length at all. What kind of triangle would this be? If you said Saline, C-A-L-E-N-E, you are absolutely correct. So make sure that you go through and you write these triangles down in your notebook and you have the measurements correctly. I'm going to give you a second to pause here and make sure that you do that, and then we're going to get into the examples, okay? All right, if you are back, that means that you have successfully copied all the 7 different types of triangles in your notebook, so you have some notes made. Ladies and gentlemen, this would be the end of our first day. We are now getting into examples here, okay? So if you need to review and watch the video over from yesterday, you need to make sure that you do that. You are in charge of your own learning. Of course, if you have questions via Google Classroom, you can ask me, but we're going to get started here. So examples 1. Earlier, we were given a problem of Marjorie and her new bunting. Remember how she wanted to make the flags? So we have her triangle right here. She needs to figure out what type of triangle she wants to make. She knows that she wants it to be 16 inches from the base to the point, right? So we have our base right here and our point right here. She wants it to be 16 inches. First, she needs to figure out what she wants the valance to look like. So she looks up a pattern. She wants to make it 16 inches from the base to the point. But that would mean if she has an equal amount from the base to the point, that would mean that our 2 sides going down would be the same length as well. If we have a triangle that has 2 equal sides, what kind of triangle is that? Look through your notes. If you need some extra help, I'm going to go up here to right here. This is what we call an isosceles triangle. An isosceles triangle is, remember guys, when we have 2 sides that are of the same length. Okay? So she would want an isosceles triangle for her bunting. So next, let's look at example 2. My friends, we have triangles A, B, C. A, B, C. Now, what do you notice about the markings in our example? They all have these lines on the lengths. That indicates that our sides are all equal in length. And with that, their corresponding angles would also be all equal in length, correct? So what kind of angle is this? This would be an equiangular. Remember how we learned how if they share the same angle size, they are equiangular or equilateral. I would accept either answer, 8th graders. All of them would work for me. So example 4, this is an easy question. What measures can we use to classify triangles? We measure them in 2 ways, via the angle or the length of the sides. I'm going to let my page clear here. And now let's go down to example 4. Example 4, we have triangle E or DEF. Angles D and F are the same. That means that their length of the corresponding side would also be the same. So what kind of triangle would this be? If we have two sides that are equal in length, we have two angles that are also equal in length. This would be an isosceles triangle. C-E-S-O-C-E-L-E-S. Isosceles triangle. In our last example, ladies and gentlemen, we need to name each of the following triangles with reference to both sides, to the side lengths and the interior angle. So we need to figure out, are each of these an isosceles triangle with equal angular angles or what? So let's look here at their lengths. We have a 3.2 centimeter sides on both sides. So if they share the same sides, it would be an isosceles triangle, right? So we have our side figured out. So we have our side. And we need to figure out our angle. Is our angle, I'll let this load for a second here. Our angle, what do you notice about our angles? We have two acute ones, but what do you notice about angle 1? That would be an obtuse. So it'd be an obtuse isosceles triangle. Now let's look, just gonna get rid of that. Let's look at our second triangle. What do you notice about our angles? We do have a symbol. It is a right triangle. What do you notice about our sides? There are two similar sides. So that would be an isosceles. We have an isosceles right triangle. I swear I didn't misspell that. The pen or the computer didn't transfer it correctly, apparently. All right, so let's look here. What do you notice about our angles? What kind of angles do we have? We do have an obtuse. We have another obtuse triangle. What do you notice about our sides? None of them are the same. So if we have no similar sides in length, what do we call that? Go back up and look through your notes if you need to. But you would find that it is a saline triangle. So ladies and gentlemen, that brings us through the rest of our examples here. Your assignment is to review here and then go on to the Google form, and you will have a 5-question assignment to follow up on. Review here, use your notes on that, and contact me via Google Hangouts if you have any questions. Otherwise, I sincerely hope that you guys have a wonderful day. Thank you very much.